Yeah, I still have it.
Oh, there we go. It's working finally. Right. Okay. Hopefully it's all working. Right. Last week we were working on sets, and you guys had to create some set tests to see if you could empty, push, and pop the set. Is that right? Maybe. Don't know. It's been to bed since then. Have no idea what we're doing. Has everyone finished with that? Got different tests for the sets. So you should have the ability to push new items into the set, and you should be able to test to see if an item doesn't exist, etc. We made some fixes to the code on the set to make sure that it does work, where we return things like if value contains key equals false, add it, so we only add it. And I've got if not, tell the user through an error message, and I've got there should set an error message here as well. How do we set an error message? Magic beans. Well, what we're going to do is we're going to create a list of error messages that we can select from. It's known as an enumerated list, or enumerated type. And what we do is we actually put public enum, which means enumerated type, error message, and then we have our list inside some curly brackets just separated with commas. So the first error message is obviously no error. Okay. Okay. The next error would be item in set, item not found. So two different errors that we've got. Okay. Does that make sense, first of all? How an enumerated type actually works is that it's actually a number type. And the first item is number 0, next item is number 1, next item is number 2. And they are interchangeable with integers. You can actually put brackets int before a enumerated type and it will give you the number value. Or you can take an integer and brackets enumerated type error message and it will give you the right error message based on the integer. The reason we use enumerated types is so that we don't have to constantly write strings where the string may be slightly different. When you're checking against one string against another, you can end up with an error between the two. So if you've got case sensitivity, etc. One thing to note is that an enumerated type cannot have spaces or special characters or numbers starting the word off. Okay? So if you want to have item not found with spaces, you can't. You can use underscores, and then if you want to display it on the screen, you can tell it to replace the underscores, but you can't not have it like that. So then we're going to put a public in our my set, public error message status equals, and then if you hit a space, it will come up with error message. You hit a full stop, and you can just select from the list .ok. Because obviously when you first create the set, the error message status will be everything is fine. And we need to make sure whatever we do in our program code, we always start with setting the status to OK before we do anything else, so that any error message that occurs will only occur because of whatever material, whatever we've actually done in that particular function. So the push becomes else status equals error message item already in set, else at the bottom here becomes status equals dot item not found. Okay, so if I shrink it down slightly so you guys can see it all, I should be able to get it so you can see the whole lot. Right, let me shrink this down slightly. I want to be. Oh, I know what I'll do. Right, so if at the top I put in, you can see the public enum error message, and then you can see I'll highlight it in red. I've added these lines. And notice that the pop has now quotes around the else statement. So I've added an error message, I set the status to OK every time before I actually run the function, and then if there's an error, I then change the error message. Because you need to check not only that these things work or don't work when you're doing testing, but that the correct error message actually shows that you expect. Because your program that utilises this might expect a certain error message if there's a problem, so it needs to know whether there's a problem or not. So we're going to actually check the error message as well in our testing. So make sure that something, when it goes wrong, it not only goes wrong gracefully and actually does go wrong, but it also does give us some information about the problem error. I can use a couple of minutes just to get that sorted. What's the difference? Has everyone got all those in? Yeah. Everyone seems to stop typing, so I guess that's everyone. If you haven't, just snapshot the screen so that you guys can finish it off. So in my set tests, let's first of all on the add to set, let's start doing some asserts. So we want to, how do we actually check to see if an item is now in the set? Well, we can say a dot push, oh no, it's not push, it's pop. So pop a dot value, so 1. We should see if the item actually exists in there. We should also check that the error message dot OK a dot status. That's where we can actually check to see if the set actually is working. So if I run that, I push something and I can then just check that I can pop it and check it's okay. Now there's a big problem with this kind of test. What's the problem? Works, so it's not because it doesn't run. The problem is if there is an error in either my push or my pop code, I don't know where the error actually occurs, so I'm using both in the same piece of code. So I need to have a way of being able to test to see if an item is added into my set without having to pop it out afterwards. So I'm going to add some extra items into my set code to see if I can utilise that to make it better. So if I add this as a new vertical tab group so I can view the two. So I've got push, pop, empty. I'm also going to add in public bool contains item string key. Going to put a quote above this. This tells the person whether the item is in the set or not. The key to find. True if found, false if not. So, return values contains key. Simple as that. Just press 3 lines above the public bool after you've created it, and it will then create the 3 lines for you. So do it afterwards. So like here I've got public int number of items. Once I've created that, I then press my 3 lines, and it then forms that. I'm also going to add number of items. Now this I'm going to introduce you to another concept. What I'm going to do is I'm going to get rid of these two quotes here, and I'm going to use get return values.count. Right, this is something a bit different. It's not your standard function or method. Does anyone know what this is? Well, it's returning a counter, returning a count, but what type of object in programming do you think this is? A bit more of a complicated one. If you look at it, it hasn't got any inputs, like a normal functional method would have. It returns something, and inside the curly brackets, I've had to write the word get, and then a series of curly brackets with some coding. This is known as a property. It's basically like a global public variable. However, we can actually run some code before we actually send it off to somebody. So what's the purpose of something like this? Well, say for example, I've got my my public error message here status, and I've set it at the top here like a variable. Maybe I want to double check some code before I actually return the error status. So to the outside world, this would look like an integer variable, but internally in the code, it actually runs some code and then produces an integer variable. It's a really powerful usage, and you can actually set values as well. Instead of get, you write set. So if I wanted to set something, I could just write set, and then I'd say something, whatever it might be, x equals value. And value is the key word, which is whatever's returned to it. Don't have to worry about that because we're not doing setting. But the other thing that makes this really useful is it means this number of items is now read-only. I can't set anything. If I try and set anything, I can't remember message. So you can only actually get the number of items. So I can't change the number of items in the set. So if on here I say a.number of items, you can see I can get the value out, but if I say equals 7, it'll come up with an error message saying that property or indexer cannot be assigned to, it's read-only.
Can you make a set that contains a set?
Yes. Oh yeah, you can have sets and sets and sets and sets and sets.
Can a set of all sets contain itself in it?
Can a set of all sets contain itself within it? Technically speaking, no, because the set of itself is itself. We can't do setception in quite that way.
But then it's not all sets.
It includes all sets because of the concept of how can I put this down? It contains all the subsets that make up itself. Therefore, it contains all of the items that will be found in its superset. Therefore, it is itself. Therefore, it contains the whole set. You're right, mathematically speaking, there's a lot of swirly things that could be debated upon there. But generally, a set only contains itself by being itself. You could make it contain itself. You could, because the way computer programs actually work in real life, we use something called pointers, which I'm going to talk about today. And a pointer means that it could point to itself, and it would just end up in what's a recursive loop. And this is one of the problems that you come back with. So now I can do a test properly anyway. What I can actually check is that A, instead of popping a value, I can check that the number of items equals 1. And that now means I'm only testing push in my answer set. I'm not testing pop as well. Testing pop, right after I've pop from set, obviously I've got to add some items into my set first of all. I could actually now a.pop a and say, well, it's a set item, isn't it? Set item x equals pop a. and then we can try and make sure that x dot value is equal. We can also, just like we've got number of items, we can check that our number of items has gone down to 0. It's actually removed it from the set. We can check the error message is OK. We can also then run the same code again, which obviously at that point means that what we should end up with is an error message of item not found. In that same way, in add to set, we can do the same thing. We can try and add a new set item called A, and we should now find that item in set is the error, and we should also find that you still have one item in the list, you still have 0 items in the list, and we should therefore have tested our set correctly. You may notice at the moment I'm not using contains item. Where should I put that in my testing? What testing do I need to check to see if the item is in there or not?
Can you move your mouse, please?
I can move my mouse. Any ideas? Why have I put the code contains item actually into my set? What use has it got? Sorry?
Empty, based on what's going on.
You could use it for empty, definitely, in testing. What else? Anything else? Well, you can actually check it in all of them. So I want to check, in this particular case, contains item. I need to check that it contains item A when it's been added. I want to check that it doesn't contain item A anymore once it's been popped, etc. Yeah. So you can use that to check your item actually doesn't exist or exists as need be. You can also actually have to check, of course, first that contains item actually returns the right values by checking that by doing a whole test on contains item to check that when you test an item that's not there, it comes back with false. And when you check it when there is something there, it does come back with true. So add from set, that works. Pop from set works. So all of the methods that are in this structure so far work. And we've got ourselves a set. We're now going to move on to some of the more complex items in set theory. Okay. Now, I need to talk a little bit about classes and pointers, because this is going to be where things get a bit complicated. Has everyone got everything that's in? If you haven't got everything yet, make sure you take a screenshot so that you can catch it up as I talk about the next bit. Right, let me just orient the whiteboard. What we're going to talk about is the difference between a struct and a class. Okay? Does anyone know the difference between these two? Inheritance. Let's do inheritance, yeah, that's one thing. We're not going to talk about inheritance today, because beyond what I'm going to talk about, but you know that anyway, so that's fine. Hey, anyone know the difference between structs and class? Let me show you what they actually look like. wanted to create a structure, a struct, called myval, I've got a single integer inside equal x, and I've got then a constructor that sets x to equal 0. Does that make sense for everybody first of all? Yeah? Hopefully it's not too difficult to move that over there for a second. I'll do the same, exactly the same thing as the class. There's absolutely no difference in the code between the structure and the class itself. However, you can make changes to these two in such a way that it will start to make it obvious what the differences are. Okay? First of all, if I was to get rid of this constructor, my computer program will no longer compile, because it would say, oh, no, it would compile. One thing you have to know with structures is that every variable that's in the structure, every global variable, must be assigned to during the constructor. So if I had public int y, and I didn't set y there, it wouldn't compile, it wouldn't let me compile. Whereas a class can have null values, and it will allow it to go through. That's the first difference. The second difference, instead of having a blank constructor here in my class, I could just add equal 0, like that, on the class. If I try to set that in the structure, it wouldn't work. It would say, no, you can't set anything there, it has to be set in the constructor. And that's because of the way that these two items work. A struct, or a structure, is your own type of variable. And it's given some space in memory. So you have to set it up right from the start with some space in memory. It has to know exactly how much memory to actually give it. Just like an integer, boolean, whatever it might be. A class works in a completely different way. So, if I was to do the following in the structure, okay, so let's have this myval SMV. So this is my structure one. Equals new myval. So now smv.x equals 0. I can say smv.x equals 12, and it sets that value. Yeah, everyone's okay so far? Yeah? So I'm going to create a variable called SMV, I've got a second variable called SMV2. I set the x value to 12 on SMV. I then set SMV2 to equal SMV, and now I set SMV.x to equal 14. What is the value of SMV2.x? 12. Let's give it a try and just check. You guys don't have to actually do this. I'm just going to write it in code so you guys can actually see it. So if I just do it in a test method first of all. I'm going to call it struct versus class. So let's just make quickly a public struct myval. And just as I say, I'm going to int x. So public int x, public myval x equals 0. Okay, so structs can contain, oh that's right, they can't, can they? Oh, I need to give it an int value. So let's say int value. Okay, so I'm now going to create a myval, what do I call it? SMV first of all. So this is a struct MV equals new myval. Just set the value to 0. I'm going to do it again with the second one. And then set smv.x to equal 12. And then set mv2 to equal new myval. smv2 equals smv. smv.x equals 14. Then I'm going to do assert. So we think it should be 12 smv2.x. Let's give it a run through and see what happens. Run the tests, and sure enough, hopefully, it should be. So it's worked with the value that there was. Yeah, does that all make sense? Because obviously the value was set to 12 when it was added to smv2, and now we've changed the first value to 14. It has no impact at all on the second one. Yeah. What happens if I change this to class? Run the same thing through. It now fails. All I've done is change from a struct to a class, and yet now the asserts failed. Why? How does changing the first variable there had any impact on the second item?
Are they all like linked?
They are. In a struct, if I set one struct to equal another struct, in RAM, what happens is a second space is made, and all the values that are in the first one go into that second one. Simple as that. Yeah, does that make sense? So that's like normal, as you might build. If it's a class being set to equal another class, this is why we're going to talk about it, only one copy of the class actually exists, and we have what we call pointers or references to that box. So both of them are pointing to the same box. So a class, if you set class equals a class to equal another class, all it does is set the pointer for this object to be the same as the pointer for that object. So it's really useful sometimes. Other times it can be a nightmare in programming trying to work out why something's changing value in tune. Is that class being changed somewhere else? Does that kind of make sense to everybody? That when you talk about like a class X equals whatever, all you do is actually set the address in memory of where to find that class. So if you say class equals class, it sets the first variable to equal the same memory location as the second variable. So changing that first one will change the second one. It doesn't happen in the structure. Why is this important and why am I covering this with set theory? Because with the sets that we've created, we have used a struct for our item. Okay? That means if we change an item in a subset, or we have like the same item in two different sets, we change it in one place, it will not automatically change in the other. What we actually want to happen in set theory is that if an item is changed, no matter if it's in a set, subset, whatever it might be, it changes everywhere. Therefore, instead of using a struct, we need to change our set item to be a class. It will not change any of the code. So we need to double check that now. Let me just get rid of my test method for struct versus class. I'm just going to run all my tests for my set to double check that they still work, even though I've changed it now to a class. It's one of the benefits of testing as you go. You make an update, you can check to make sure it hasn't broken anything anywhere.
Mine's broken.
Well, yours would have done. Mine's yours broken. I'm guessing that we won't do it. They actually will. Yeah, it's
He's like that. It's like that.
Really, it should work. That's weird. That error should fail. But anyway, it works. That's fine. Okay. Why are we doing this? Because we are going to be able to have items that we can set to multiple sets. So,
On my test fail.
when you want to set Octaset. Okay, let's see where that is. Actual 0. That should actually.
What? So what? It was a 0 and a 1. Yeah, 1. I mean, change it from stroke to a comma. At the top. You know where it was? Is it working?
Oh, right. So, that's
See where it says top public stroke set.
It's-
Right there. I'll click on the one.
Probably not. That's it.
Must be a 1. 0. James, you know your tests and you have to find routine plans. So it's
Wait, what's 0?
Is everyone else's test working?
No.
Right, I'll come round.
Fucking hell. Pretty sure you can get flat.
Anyone else? Who else?
Yeah, James
That's-
is
Apart from sets,
It's not the same error as mine.
You press enter, you press that.
Yeah, probably.
That's really annoying if I have to do that. You need because literally, if my child says it's it wouldn't bother me. It wouldn't bother me.
Is yours working
Yeah,
okay?
it's not
Is yours working okay now, Josh? Okay. Okay, so everyone seems to have theirs working okay now. Right, so I've explained the difference between a class and a struct. So, let's see if this works. It won't, but let's see if this works. Item in 2 sets. Okay, we're going to create 2 sets in our test. We're going to have sets A and B. And then we're going to have a set item. Yep. Just ignore all that bit, that's coming later. Value equals new set item. I'm going to have my name is going to be Chris, and my value is going to be 2, which is my current IQ this morning, or how many cups of coffee I need before I survive the day. So A dot push value, B dot push value. So I've now set my item in both A and B. Okay. So now what happens when value dot value is changed to 4? Well, what should happen, item out of A equals A dot pop Chris, out of B pop Chris, we're going to check that both out of A and out of B are equal, and both of them should equal 4, because as I've explained, if we're using classes, changing it in one place should change it everywhere else. However, if I run this code, it fails. And where does it fail? Fails out of A value, out of B value. Oh, sorry, that's me making a mistake there. Sorry. Out of A and out of B has to actually pop from different ones. I thought it shouldn't actually fail on that, it should fail on the other test. That's better. It fails on the other test. The question must be, why did it fail? Which the 2 tests it failed on?
Do we have to put 2?
What do you mean?
Where you put Chris 2?
Yeah, put the value 2. You can change the name from Chris to whatever you want.
Okay.
years. What the fuck am I doing? We've just proven that changing the value in one changes the value in the other as a class. It doesn't seem to be doing that in our sets.
You seem to have quite a bit of errors on the right hand side.
On the right hand side, yeah, that's where all the errors are occurring in one of the tests. That's what all it's saying is one of the tests causing an error. It's deliberate at the moment. Probably won't be in the future, but it's deliberate at the moment.
Does it have to equal 4?
I'd like it to change from 2 to 4, yeah, and it should mean that it equals then everywhere else 4, but it doesn't. There's some mistake somewhere.
Is it in this test match that the mistake is, or is it somewhere else?
It's in the actual set itself. the mistake is.
Okay, there's a lot.
I'll give you guys 5 minutes.
I've got some nerves, Chris.
Okay.
Surprisingly.
Dun, dun, dun. It's got
I don't know why. But how would you know? I just really worried that wrong.
yeah, is this you trying to fix it?
Yeah, I did what you did. Oh, no, so that's actually
No, I tried. I don't really know what happened. You know, there's different words.
Right, one more minute, guys, before I reveal how exciting the answer. I'm sure you're all desperate to know. You can see you all, hanging on the edge of your seats in anticipation. Well, the problem lies, so I can't bother to wait anymore, with the way that we actually push and pop. If you look, all we're actually storing in the hash table is the value itself, not against the key. We're not storing the object. And when we pop, we recreate a new set item each time. What we need to do is, for the key of the item's name, is actually store the entire object. So instead of push going to add item name, item.value, just going to add the item. And what you're going to do to get rid of the set item, or to get the set item out, is the following. So you're now going to, I've just changed that line and that line. And now what should happen, if I run the test, it should theoretically pass, which it does. So now, if an item is in two sets, changing it in one set will change it in the other automatically. Because it's the items that are important, not the sets themselves. So instead of storing an integer in my list, I'm actually storing the actual proper class item itself, and I'm pulling that class item back out again from the sets. But notice, when I pop the item out from one list and it's removed from that set, it doesn't delete it from memory, because otherwise we wouldn't be able to pop it out from set B. But also, if I make changes after they've been added to the set, it changes in the set as well, which is as you want it to be. Because if you've got a person and you remove their eyes and replace their eyes from blue ones to black ones or something like that, you want them to have black eyes in all the different variations of themselves, not just in one. Or you have to go and find them in every single set to do that. Okay. So we now have a set that works correctly to what we expect. So it means we can actually check to see if an item exists in more than one set.
Should that test pass?
That test should pass now. Does your test fail still? Right.
Never mind. Yes, James is broken. What am I missing? Wait, what is that one? Oh, I think. Okay, I did boy. I don't think of a name. Exactly. I don't know really what I've done. Wait, let's go for it. Wait, I have more. Yeah. Oh no, I didn't know that.
What should fail then?
Everybody knows what this class. They obviously haven't compiled for some reason. I'm still using the other code. Yeah. So you should find that works anyway.
No.
No?
You're going to be coming over here quite a lot.
So that's this I can. Right, let's have a look. Expected for actual 0. 0? Could it be any further out? I don't know. Let's find out. Okay, so
No, wrong bracket. No, it's not. And then delete the bracket. False, anyway. And then up here. Let's get rid of
oh, no.
Congratulations, you have now done it.
A and B.
Would you like
There's
to
some values we can check. Let's push the two. Then I'll set the names to
You're
so
with
values,
Let me just reverse.
is 4, is 4. What else? Oh, sorry, it's my mistake. Right,
And the
where's
next-
that then?
Literally,
Yeah,
actually, waiting
you
the
take it
there's
as
a bridge.
twice, so
Oh, the bridge
obviously
has
that-
no tipping, so you just go down into the river
so
and
that's
up
where
again.
that's
Yes, correct.
There's no.
Has anyone else got any problems? Okay, let's just try something else. What happens if we say R equal and we take these two classes out of A, out of B? Let's run it and see what happens. And it still passes. Okay, so out of E equals out of B. Is everyone okay with that so far? Yeah, because we've got the same object we've pushed in twice. Now I'm going to make a quick change to this code to show something else that's problematic. Right, instead of doing these poppings, I'm going to set each of these to be a new set item. Okay, the poppings, yes. So, should this test now pass or will it fail?
Am I using it as a problem? It should fail.
Should it fail? Okay, let's run the test. And it does fail. Why does it fail? Well, the values work. Oh, actually, that one's going to fail anyway. So, but that's not the one I was going to look at. That it still should fail. Yeah, well, that's good. Even though out of A and out of B have exactly the same values, the same key and same number, because they are not the same item, they're not the same item in the class, each of them is slightly different. Because actually, when you're measuring if these are equal, it's saying, is the memory location of these the same? Does that make sense? Now again, this is actually a good thing for our set theory. Because when we've got items in a subset, we want to check each one is identical in another set. We can see if they've got the same things in them. We don't want to look at the values and say, well, is the value the same? We might want to look at, is the actual object the same? So this is actually a good thing, not necessarily a problem, but it is something you have to be aware of. So, this should still pass, or hopefully it will pass now. I've run debug test, but it will still work. Go into debug mode then, run the test. I've got breakpoints on there. Let's just continue. Okay, so where do we go from here? Well, what I'd like to do is have another function in my set that is as follows.
Doesn't matter where it goes.
No, it can go anywhere at the moment. I'm just going to return true at the moment. What I want to do is something similar to what Alex was saying earlier. I want to send another set into a set and say, is this set contain all the same items that's in my superset? So what I'm going to do is I'm going to have the equivalent of, or I want to have the equivalent of, here is my entire set full of items. These 3 items are in a subset. If that's the case, I want it to be true. Say that this, there's an item in this red subset that isn't in the main set, actually equals false. Does that make sense? Now, it doesn't matter if there's extra items in the main set, it's whether this is the subset of. Okay? So what I'd like to do now is create a code that does that, that actually checks to see, you should be able to work out what I've been talking about just a moment ago as classes. If it does contain a subset, it returns true. If it doesn't, it returns false. And I want to create the tests to make sure that this actually works correctly. So you should check to see that it accepts when there is a subset, it rejects when it's not a subset, and what happens if you do check the subset and check the other one. What happens if both sets are the same?
Can you link sets in sets and sets and sets and sets to keep going?
Yeah.
How quickly would that slow the computer down? Or would it not at all?
Because it's all pointers.
Okay.
Yeah. So yeah, I can have 1,000 different sets, and then, you know, I have 1 million items in a big set, and I have another set with 400 of those items, and so another subset with another 300 of those items, and, and so on and so on and so forth. Because they all actually point, and it wouldn't take up any more memory either than the main set.
Okay.
Which is one of the benefits of it. Okay, I shall stop the live stream broadcast now, so for anyone who's at home, I'm James. He's not online anyway. Right. Let's